Hello and welcome back. Welcome back. I'm John, an old YouTuber and PC gamer. It's Sunday today. We have a nice weather. I'm from Denmark in Scandinavia, and this is my YouTube channel, Monko TV. I have recorded video for fun soon, 8 years, like August 2014. So that's soon 8 years. I think I have to remember to introduce myself, what my name is. My name is John and I'm a YouTuber. I'm from Denmark. That's north of Germany in Europe, because I have to remember that people everywhere around the world could be watching and understand English. Could be from India or South America, North America, could be Australia. That's many are recording video for YouTube in English that don't have English as their mother language. They're not speaking very well English, but that's just fine, because that's better to make some video in English that's not so good than never do it, because I like to go travel later. I like to go travel in Europe and record a lot of video in English. So I have to practice my English anyway. Yes, I download all this from the Wikipedia, and I can read English. I do that. I read English a bit high level, like high school and university level I can read, but this text is very technical. It's a lot of numbers, a lot of technical words about computers. So next I will read this. I've just uploaded about the Intel 4004. That's the first 4 bits. And later I will download what 4-bit is, what is 8-bit, what is 16-bit, what is a data bus. But I'm not start to record that yet, because I think we have to do this CPUs. We have to do the 8000, the 8008, the first 8-bit, and then the 8086, the 8186. I already did. That was the first one I did today. Then we do need to do the 8286. So let's do the CPUs. Then let's do the Intel, but the Intel that's 46 pages. But I have a playlist called Monko TV, looking at PC gamer hardware. That will be all my videos about gamer PCs. I have not used the big gamer PC desktops. I'm not using for many years, because I'm really enjoying this smaller laptop, gamer laptops, because they're not making a lot of noise. I only have a small apartment. I've been living in a one-room apartment many years before this, like 20 years. That make a lot of noise. If you have a big desktop gamer computer standing on a floor and running the whole day, that's like to have a vacuum cleaner running the whole day. Like this is a vacuum cleaner to clean the dust. It's like to have a vacuum cleaner. Actually I have to vacuum clean, because we have a lot of dust everywhere. That's the same places we have the dust. I know exactly where it is. It's there and there. That's not me going and put all this dust there. I know where it is, and around here. This corners, the dust line to be here. But now I've been walking here many times. I'm moving the dust. Yes, but just do this for fun, and this can maybe help some other like me that don't have English as the mother language, and maybe they have bad eyes. I start to get old, my eyes is not so good, so sometimes my eyes are so tired I have problem reading. And could be people that are handicapped. If you're sick and laying in your bed, that's something nice. Somebody is reading. So I will do this. But I've been sitting here many days. I'll make like 100 videos, so my back is hurting because I've been sitting on this like this many days. I have recorded videos in Danish and talking like this, and the screen is far away. So, and I've been sitting and my back is hurting really bad. Yesterday I could barely walk. Yesterday I was walking like this. Yesterday I could barely get up. So that's not good. I'm sitting here so many hours. So, but let's do it. Let's finish, because maybe next month or next year I will be even older. Maybe I'll not do this. I'll just like to record when I can do it, because I'm a last part of my life. I'm 56. I'm 50 years, 6 years. I don't know if I'm live in 5 years. I don't know if I'm getting to 60 or more. Probably I do, but you never know. So I just need to record what I like to record. Because maybe one day I stop making video for YouTube, or I'm not here anymore. So I think that's very interesting to know about the old CPUs. So I like to read it myself. So I will just make a read, then I will follow with this. This is to a drone. This is to a propeller to a drone, yes. But now this introduction is super long. So I was flying FPV drones. I was trying to learning. This is propeller for that. I use when I'm recording video. I got some old more there. Like there, that's a black one. But I like the red one. I have a lot of propellers, many hundreds. We have up there. So this is wonder why I use this, because that's very good to point and look at that. And if I'm using the map, this is Denmark. I'm living up here. Yes, let's read it. But this is 8 pages, but some are like 50 pages or even 70 pages. That would take many hours to read. So let's do, and this is Adobe Acrobat in Danish text. Let's read it loud. Read to the end of the document.
Intel 8008. Intel 8008 KL Intel C8008-1.jpg. An Intel C8008-1 processor variant with purple ceramic, a gold metallid, and gold pins. General information launched mid-1972, discontinued 1983. 1. Designed by Computer Terminal Corporation, CTC, Common Manufacturer, S, Intel. Performance Max. CPU clock rate 200 kHz to 800 Ks. Data width 8 bits. Address width 14 bits. Architecture and classification. Application computer terminals, calculators, bottling machines. 1970 SASE industrial robots. 2. IRB6, simple computers, etc. Technology node 10 instruction set 8008. The Intel 8008, 8008 or 8008, is an early byte-oriented microprocessor designed by Computer Terminal Corporation, CTC, implemented and manufactured by Intel, and introduced in April 1972. It is an 8-bit CPU with an external 14-bit address bus that could address 16 kilobytes of memory. Originally known as the 1201. The chip was commissioned by Computer Terminal Corporation, CTC, to implement an instruction set of their design for their DataPoint 2200 programmable terminal. As the chip was delayed and did not meet its performance goals, the 2200 ended up using CTC's own Intel-based CPU instead. An agreement permitted Intel to market a chip to other customers after SiCo expressed an interest in using it for a calculator. Contents. History. Design-related processor designs. Features. Example code. Designers. Second sources. See also. References. External links. History. CTC formed in San Antonio in 1968 under the direction of Austin O. Gus Roche and Phil Ray, both NASA engineers. Roche, in particular, was primarily interested in producing a desktop computer. However, given the immaturity of the market, the company's business plan mentioned only a teletype Model 33ASR replacement, which shipped as the data point 3300. The case was deliberately designed to fit in the same space as an IBM Selectric typewriter and used a video screen shape to have the same aspect ratio as an IBM punched card. 3. Although commercially successful, the 3300 had ongoing heat problems due to the amount of circuitry packed into such a small space. Physical specifications: transistors 3,500. Package S, 18-pin DIP. Socket S, DIP 18. History: successor Intel 8080. In order to address the heating and other issues, a redesigned starter tot featured the CPU part of the internal circuitry re-implemented on a single chip. Looking for a company able to produce their chip design, Roche turned to Intel, then primarily a vendor of memory chips. 3. Roche met with Bob Noyce, who expressed concern with concept. John Frasanito recalls that Noyce said it was an intriguing idea, and that Intel could do it, but it would be a dumb move. He said that if you have a computer chip, you can only say own chip per computer, while with memory, you can sell hundreds of chips per computer. 3. Another major concern was that Intel's existing customer base purchased their memory chips for use with their own processor designs. If Intel introduced their own processor, they might be seen as a competitor, and their customers might look also here for memory. Nevertheless, Noyce agreed to a $50,000 development contract in early 1970. Texas Instruments, T, was also brought in as a second supplier. T was able to make samples of the 1201 based on Intel drawings, but these proved to be buggy and were rejected. Intel's own versions were delayed. CTC decided to re-implement the new version of the terminal using discrete TTL instead of waiting for a single-chip CPU. The new system was released as the DataPoint 2200 in the spring 1970, with their first sale to General Mills on the 25th of May, 1970. 3. CTC paused the development of the 1201 after the 2200 was released, as it was no longer needed. 6 months later, SiCo approached Intel, expressing an interest in using the 1201 in a scientific calculator, likely after seeing the success of the simpler Intel 4004 used by Bizicom in their business calculators. A small redesign followed under the leadership of Federico Fagin, the designer of the 4004, now project leader of the 1201, expanding from a 16-pin to 18-pin design, and the new 1201 was delivered to CTC in late 1971. 3. By that point, CTC had once again moved on, this time to the DataPoint 2202, which was faster. The 1201 was no longer powerful enough for the new model. CTC voted to end their involvement with the 1201, leaving the design's intellectual property to Intel instead of paying the $50,000 contract. Intel renamed it the 8008 and put it in their catalog in April 1972, priced at $120. This renaming tried to ride off the success of the 4004 chip by presenting the 8008 as simply a 4 to 8 port, but the 8008 is not based on the 4004. The 8008 went on to be a commercially successful design. This was followed by the Intel 8080, and then the hugely successful Intel x86 family. 3. One of the first teams to build a complete system around the 8008 was Bill Pent's team at California State University, Sacramento. The Sac State 8008 was possibly the first true microcomputer, with a disk operating system built with IBM Basic Assembly Language in PROM, all driving a color display, hard drive keyboard, modem, audio /paper tape reader and printer. 5. The project started in the spring of 1972, and with key help from Tektronix the system was fully functional a year later. Bill assisted Intel with the MCS8 kit and provided key input to the Intel 8080 instruction set, which helped make it useful for the industry and hobbyists. In the UK, a team at SE Laboratories Engineering, EMI, led by Tom Spink in 1972 built a microcomputer based on a pre-release sample of the 8008. Joe Hardman extended the chip with an external stack. This, among other things, gave it power fail-safe and recovery. Joe also developed a direct screen printer. The operating system was written using a meta-assembler developed by L. Crawford and J. Parnell for a Digital Equipment Corporation PDP 11.6. The operating system was burnt into a PROM. It was interrupt-driven, queued, and based on a fixed page size for programs and data. An operational prototype was prepared for management, who decided not to continue with the project. The 8008 was the CPU for the very first commercial non-calculator personal computers, excluding the Datapoint 2200 itself, the US Selby kit and the pre-built French Micro N and Canadian MCM/70. It was also the controlling microprocessor for the first several models in Hewlett-Packard's 2640 family of computer terminals. Intel offered an instruction set simulator for the 8008 named INTEP/8. It was written in Fortran. Design i8008 microarchitecture. Intel 8008 registers 1312111007060504030201010. Bit position: main registers: A accumulator, BB register, CC register, DD register, EE register, HH register. Indirect: LL register, indirect. Program counter, pushdown address call stack ASCII level 1 AS call level 2 AS call level 3 AS call level 4 AS call level 5 AS call level 6 AS call level 7 flags CPZS flags. The 8008 was implemented in 10 micrometers silicon gate enhancement mode PMOS logic. Initial versions could work at clock frequencies up to 0.5 MHz. This was later increased in the 8008 to 1 to our specified maximum of 0.8 MHz. Instructions take between 5 and 11 T-states, where each T-state is 2 clock cycles. 7. Register loads and ALU operations take 5 T20s at 0.5 MHz. Register memory 8 T32s, while calls and jumps, when taken, take 11 T-states, 44s. 8. The 8008 is a little slower in terms of instructions per second, 36,000 to 80,000 at 0.8 MHz, than the 4-bit Intel 4004 and Intel 4040. 9. but since the 8008 processes data 8 bits at a time and can access significantly more RAM, in most applications it has a significant speed advantage over these processors.